Hello, I once created an application visualizing how a helicopter flies, and now I'd like to create a new version of this application with my knowledge I have now. If everything goes well, this will be a tiny devlog series with a few entries, and the application will be a web app. And now I'm recreating some older projects of mine, and this time I also like to try to create such a devlog series showing the whole process of creating such an application step by step. At first I created some game objects in Blender 2.9. I needed something to work with, and maybe I will upload the long video as a second part. But during this process, many parts of this helicopter will change continuously. And the important part here to mention is that when you export this file as a FBX file, I had to make sure that in the hierarchy is only one series. They have to be in line or have to be at last the first child, and it didn't work for me if you have multiple children in this hierarchy, but this doesn't matter because I will parent those game objects within Unity later on, so I keep all my game objects in the very same position of the hierarchy. And also what is important is that you choose the option apply transformation, and you also set the options for forward is minus z forward and up is y up, so I am able to work way easier with the transformation procedure within Unity. After many tries and errors, I managed to arrange the rotation and positions of the specific parts. Depending on the input, now you see how the red disk is rotating into a specific angle, and also the yellow disk is rotating around, and I have those 4 pumps around the main axis which gives the position, which gives the height of the red disk. Unfortunately, I didn't manage to use a controller for the steering, but I use a regular input system of Unity right now, and I hope to change this in the future because this will be an important part later on, which positions the controller, the joysticks will have for the steering. Here we see the source code. At first I define which objects I'm going to need. I like to search for those game objects in the start function, because if something changes within Unity, it's easier to rearrange the scripts. This may not be good practice. During this procedure, I define the parents of the game objects, but here I have to look especially on the order in which I give the parents, and I define the other objects. I also like to have one main game object I created in Blender, and within Unity I just create a copy of this game object. As an example, let me give you the blades. I have created one blade and I just create 3 additional instances of this specific blade and position this blade. The interesting part here is that I like to have the blue rods here and I position those, and then I use a function look at to orientate those rods, and I do not have a specific target point, I do not have a specific target, but the target I'm looking for is within the green blade. So I have to use transform point, and within this green blade object I go to the position minus 0.15 and minus 0.3 within this green blade, and now my blue rod will look at this specific position within this green game object. So the alternative would have been that I create an additional game object within this green blade object and look directly to this, but this appears to be more comfortable. A very important function is the angle of rotation to angle of deflection function. This function is being asked for at many positions within the script. This function gives out the rotation angle of the green blade towards the air molecules, and this angle is depending on the rotation angle of the main axis. It also has to consider the pitch going upwards or going downwards. This specific factor is independent of the current rotation angle of the main axis. We are allowed to make our lives easier, and we are allowed to use here the Taylor approximation. That means, as an example here, we rotate the lever below of a specific angle. The lever above also rotates about a specific angle, but the lengths of both levers are different, and we have to consider this difference. In reality, we would have to consider for each movement the x, y, z changes, but we assume that we are only moving our anchor of the blue rod in the y direction. We are allowed to use the Taylor approximation, and we see that the length of the arm above is only half as long as the length of the lever below. For this very reason, the angle above will always be approximated double the size of the changed angle below, but only for small angles this is approximated identical, or let's say the doubled value here in this example. If I want to use a look_at function in Unity, I have to orientate my game objects in Blender accordingly, and I also have to consider how I'm going to export the axis, like I mentioned before. Here I have to make sure that the negative green arrow of the Blender system will be the direction I'm looking at later on within Unity. So I had to make sure that the positions and the rotation of those game objects are 0 as a base, and within this base my vertices go towards the negative y direction. At this point I forgot to design also this lever here, and there had been some tries and errors, but I finally managed to create those objects here accordingly. Now we can ensure that the yellow disk always stays on the red disk and always has the correct angle according to the main axis, which is rotating, and so the yellow disk isn't allowed to rotate more or slower around the main axis. I'm not proud on the way how I implemented those game objects. After a few tries and error, I managed to make it look like it's working accordingly, and I'm making some rounding assumptions here, but I can live with it, and it looks like it was supposed to look this way. Now at the end of this part, I wanted to show how I create something like a pizza edge system, visualizing the position of those blades at every point in time. But I need a coffee first. Another one. Here we see how I implemented this pizza edge system, and depending on the angle of this red disk, I see for many possible angles how the orientation of the specific green blades would be if there was a green blade at this specific position. I think you get the picture what I'm trying to say, and yeah, it looks better than I assumed. And I'm also going to show how the code looks like. Here is a new part for the pizza edge system. I am creating a blank array of game objects, and the 0 position of the array is the very first game object I created within Blender, and all upcoming entries of this array will be clones of this specific game object. And in this specific part of the start function, I wouldn't even need to orientate those, because I'm going to regularly orientate those blades within the update function. And here we see how I go through all of them, and for each blade I calculate the angle considering the specific angle I'm looking at, and now I get the new angle of orientation. For the next upcoming video, I'm thinking at the moment to create a dust particle system visualizing the force which is pushing the helicopter up into the air. And I'm thinking at the moment to use game objects for this system, and I'm probably going to manipulate those game objects with the vertices and UVs. I also have to think of a system visualizing the steering of the helicopter, because if you push your stick forwards, I assume the helicopter will also fly forward, but the angle of the red disc will be tilting sideways, and this has to also be visualized how and why this is useful. Let's see. Okay, thanks for watching.